everybody. My name is Ryan Clarke, and I'm going to be talking about some of the electronic properties for silver, palladium, and indium nitride. First off, the electronic configuration. Um, we can use our triangle of SPDF orbitals to arrange the electrons. Um, For silver, we have atomic number of 47, so it has 47 electrons. Can arrange that like so. However, um, having a 4D9 orbital is much less stable than a 4D10 orbital. So in real life, we will have this 5S1 4010 and not this. For palladium, the atomic number is 46, so it's going to have the same structure except one less electron in the d orbital, and we can put these two electrons in the 5s orbital into the 4d orbital to make a much more stable structure. Um, for indium, with an atomic number 49, it will have this 4010 5s2 5p1, which is stable as it is. Nitrogen only has an atomic number of 7, so it'll have a 1s2 2s2 2p3. And if we wanted to write these in a shorter fashion, we could take everything from the 1s orbital up to the 4p6 orbital can be written as KR or kryptonite, krypton, sorry. And that will shorten up that. Up next, the band gap for our semiconductor. Indium nitride has a band gap of 0.7 electron volts, which is a fairly small band gap. Um, Indium by itself is just going to be a metal, so it's not going to have any band gap. And similarly, nitrogen is a gas by itself, so it also has no band gap. However, nitrogen is special in that if you arrange it in a two-dimensional sheet, it actually acts like a semiconductor and exhibits a band gap of around 3.7 electron volts. Um, and that's just for two layers. If you keep increasing the layers, this band gap will decrease. Um, for doping of indium nitride, for p-type doping, I would suggest we use magnesium. Um, the magnesium is going to replace the indium, and indium has 3 valence electrons, while magnesium has 2. And I know this based on the periodic table down here, as magnesium is a group 2, and indium is a group 3. Uh, so that will create positive charged holes with that lack of an electron. And magnesium also has a slightly smaller atomic radius than indium, so it will not cause any issues in the lattice structure. For n-type doping, we would suggest you use silicon because silicon is a group 4 element, so it has 4 valence electrons, and that will replace the 3 in indium, which will create a negatively charged free electron. And silicon atoms are also smaller than indium atoms, so it won't create any issues in the lattice structure of the indium nitride. And up next, Laurent will explain some more properties.
Hello, my name is Laurent Kingue. In this slide, we'll be going over free holes and free electrons. For free electrons, we need the mobility, which is right here. It is 3,200 centimeters squared. Concentration and which is 10 to the 18th power centimeter cubed, and electrical conductivity, which is 10 to the 5th. Here's the formula we need for free electrons and the estimation right here. For free holes, same things you need. You still need mobility, concentration, and electrical conductivity. You get 40 centimeters squared. If the concentration, you get 10 to the 16 centimeter cubes. But for our elements, we can't really have a specific figure, so it's particularly low. We just know it's very low. And for our final slide, we will show like these elements, what they use for electronics, LED, and photovoltaics. Metal alloy AGPD for electronics are used in electrical contact with resistive films and connected due to excellent conductivity and corrosion resistance. So they're pretty durable. The LEDs and the photovoltaics aren't directly applicable, but can show a very high conductivity and material for interconnections. Radium nitride for electronics, they are very ideal. Very high speed photons and quantum devices due to its low band gap. LEDs also use radium nitride in the form of alloy, right here, and is used for light emitting layer in modern blue and green LEDs. Photovoltaics used in solar cells, particularly when used in alloys, like this one, to achieve optimal optical match to the solar spectrum. That is it for all our slides. I hope you enjoyed the video. Have a great rest of your day.